Hi, everyone. Okay, so I have some good news and I have some bad news. Good news is happy Math Monday. We're back to Math Mondays. Isn't that so nice? Bad news is I think Spotify is down for me. So we're not going to have our normal, nice, kind of chill soundtrack in the background, and I'm sorry. So you're going to have to just deal with me and no music. But hi, Mediocre Gamer. Hi, Raw Yolks. And Strawberry Jesus, and of course Loafbone. Welcome everyone. I'm getting a few things set up here so we can all just hang out for a few minutes. Oh my goodness. Hopefully everyone had a good Monday. Happy Monday. Spotify, why you do this to me? Oh? Success? No? Possibly? Ooh, we might have music after all. Oh, let's test this out. Of course it comes back. Right as I right as I start streaming, but let's see. I'm going to turn the audio down a little bit so I don't blast your ears out. Let's see. Hi, Jiggly Enough. How are you? Let's see if this works. There we go. Got some music after all. All right. Sorry, just tweaking a few sound things. Normally I do this before stream, but literally Spotify wasn't working until now. So, but there we go. Good. We've got a little bit of some background music. How are the levels? Is everything good? And hi, Cootie Juice. Thank you. Yeah, it's International Women's Day or something? I'm so bad with like the holidays, the various like celebrations and everything. I'm not good at keeping up with them, but thank you nevertheless. Good. Thank you, Jiggly Enough, for testing the audio out. So I know it's been a while since we've had a Math Monday. I was actually looking at my GitHub, making sure that I had like all the notes and everything for, not for Math Monday, but for Science Sunday. And I realized I did a single Science Sunday. Like Fundamentals of Data Science stream in February. Oops. Yikes. It was such a busy month. So thank you to all of you who've stuck with me through the super busy February. And are celebrating my birthday month with me. Woohoo! I'm so excited. Let's see. Do I really have to keep this super bright? Ugh, silly green screen. Nevertheless, yep, I will be celebrating International Women's Day by teaching all of you some math. Just like having that sort of, I don't know if all of you get like this at the end of the day, but especially if you've been really busy, and for me, I was coding into like kind of the last minute. There's just this moment of like, okay, transition. Getting out of like, introverted, I don't talk to other humans mode and getting into streaming mode. Hi, Lordly Dawn. Hi, Carlos of Gingerfell. Well, Lovebone, that's a little, that's an image. That's certainly an image. Okay, so since it's been a while, I know it's been, like I said, it's been a little longer than I'd like. I figured we could start out with just a little bit of a review of what we've talked about previously before we start diving in, because I really wanted to like ramp things up a little bit, get into some cool new stuff today. So let's get this whiteboard going. What's a loafbone? Well, that's actually a very good question. You'll have to ask Loafbone that. Messing with the sound. Sorry, friends. I turn it up for all of you, but I'm weird when it comes to music, and I struggle to talk over music. It distracts me. So I have to turn it super down for me, but make sure that it's still up for all of you. Extreme integration today. Not quite, Cootie Juice. Not quite. But I do have some cool stuff that we'll be doing. So we're not quite to calculus yet. Someday I hope so. That will be pretty cool when we get there. All right. Those are the problems I want to do later. Sorry, Cootie Juice. All right. And there we go. All right. Math Monday. I'm so excited we're doing these again. And do not worry. Yes, next week's Math Monday is going to be Pi Day themed. So we'll take a little bit of a break from algebra. Maybe we'll do some algebra, but I'll talk all about pi. So, and Stove Douges and Ahmed Gaber. Welcome to Math Monday. Hi, how are you? Cosmic brush time. I know, I love this brush so much. And yeah, it's a long-term goal, but you know, I'm planning on doing a lot of tech streams, and I'm hoping to start the Microsoft sponsored streams in March. So, you know, aim high, I guess. And if I don't make it, I don't make it. But you know, it's a big birthday, all right? So I gotta dream. All right, so what have we talked about previously? Review. This is also good for me because I need to review all the stuff that we've talked about. So, oh, thank you. I'm glad I pronounced it right. Okay, so what have we talked about? You all remind me. You all, because you're the ones that listen, right? I just babble to myself for, you know, for a couple hours every Monday. And I forget what I say after I say it. No, I'm joking. So what have we talked about? Remind me. What have we been doing? Babbling can be good for learning thrashing code if I organize myself a little bit. And hi, Zug Addict, how are you? So I know some things that we've talked about, right? So we've talked about variables and expressions. Oh, wait, hold on. No, none of this. I'm going to be good today, which means I'm going to actually work on my handwriting. Exactly. Now I feel like everyone's watching and the pressure is on. No, but I just want to make sure my handwriting's a little neater for all of you today. Okay, so we've talked about variables and expressions. We've talked about functions and equations. What else have we talked about? I see you selected a new font. Not just trying hard to make handwriting look nice font. And hi, Jay Shady, welcome. And Cootie Juice, so you have to do a lot of math. So actually, I've got to get back into my YouTube habit, right, of reading out the questions. You ask, how are you so good at math and you're not even a mathematician? So a couple of reasons. One, I love math. And two, to do physics and to do a lot of machine learning, you need a lot of math. So just like any other skill that you might have, if you don't use it every day, you're going to forget it, and that's normal. That doesn't mean you're bad at it, but practice makes perfect, right? So I get a lot of practice. And that's okay. You say you forget everything about math, but you have a minor in math. Honestly, it's not even about the education. I don't remember half the classes I took in college, but the thing for me is if I use it every day, or, you know, if I use it regularly enough, I remember it. But if it's been years since I've used it, like, trust me, when we get to calculus, I'm going to have to do some review for myself too, because there's totally areas of calculus that I don't use that often. So let's see, what's up? Odd one. You ask if I would date someone less smarter than you. I think intelligence is really relative. I really do. So would I date somebody who knows less about math than I do? Of course. But I like there to be a balance. So I like to learn from my partners just as much as I like to teach them. So as long as there's that balance, I feel like it's, you know, It's a healthy relationship. So, Jiggly enough, you say what stuck with you from last Monday was the distributing way of solving equations. Can you talk a little bit more about that? What do you mean? And yes, Jay Shady, we're gonna get there. We're gonna get there. Cootie juice. I have cootie juice. Ooh. Math knowledge balances with knowledge about release dates of Nintendo amiibos in May, March. What? Oh, jiggly enough. Okay, so yeah. So we talked about, let's see, approaches to solving linear equations. What else have we done? And On, thank you so much for following. Welcome. Yes, exactly. Teach me about the release dates of Nintendo amiibos, Ray March. No, in all seriousness, everyone's got those like weird facts, right? I'm a repository for really, really strange random facts, so I understand. Hi, Van Buchan. I'm doing well. How are you? Okay, so let's think. Variables and expressions, functions, equations, approaches to solving linear equations. We kind of started a little bit of graphing. So maybe intro. We'll put intro. What else did we do? Obviously, talked about this and why that's a loaded topic. Hi, Jay Shady. Yeah, we did a little bit of graphing. So just to kind of start to get the idea of why we do it, what it looks like, but nothing too major. My favorite color is not blue, Cootie Juice. Oh, snap. Oh, snap. My favorite color is actually green. So I just can't wear a lot of green because I have the green screen. But that was actually something that was challenging when I got the green screen. I realized I have so much green clothing. So I had to find other stuff to wear on stream that isn't like my normal color. So green is my favorite. It's the color of plants. So, Cootie Juice, don't worry about it. Hi, Katya. Welcome, welcome. Okay, what else am I missing? We did a little bit of inequalities, I believe, right? Inequalities. What else? Oh, right. And in this, I guess we'll do a little like corollary here. We talked a little bit about some properties, right? So we talked about identity properties and how we can exploit them to solve equations. But I know it's been a while. For a lot of you. So look over this list and let me know how you're feeling. If we need to just do a brief review of something, or if I can just quick, I'm not going to spend a whole lot of time, but I'd rather everyone kind of be on the same page today while we move forward. And let's see. Green is supposed to have the most visible shades of color. I've worked in a lot of different wavelengths of light, and I can't think off the top of my head if that's true or not. So, haha, Cootie Juice. I appreciate the gesture. Identity properties. You got it, Jiggly enough. So this is where, remember that I don't want anyone memorizing these property names, okay? Instead, I'd rather you think, okay, identity, what is identity? It means like yourself, right? So think about looking in a mirror. You look in a mirror and you see yourself. So you get the same thing back. So identity properties, do a little mini review here. We talked about two of them. We talked about, started going off in strange directions there. We talked about the identity property of multiplication. And again, don't memorize what this means, just break it down. So identity property, you're going to get the same thing back, multiplication. So we're going to take, our favorite variable here, x, and we're going to multiply it by something, and we're going to get x back. What do you think's missing? 1, right? So this is the identity property of multiplication. You multiply by something and you get the same thing back. Similarly, we talked about the identity property of addition. So similarly, you add something, you get x back, right? But in this case, instead of multiplying by 1, we're adding by 0. So there are so many times I've seen, poor people in school trying to memorize these properties, like flashcards, all kinds of stuff. Just break down what the words mean. Identity, you get the same thing back. Multiplication, so set it up. I'm going to multiply something by x, and I'm going to get x back. And then just fill it in. And you'll remember the properties better that way. Versus, just trying to memorize, identity property of multiplication. Flip the card, that's this thing. Because that's not going to actually stick in your head. But hopefully, jiggly enough, this was a good review. We use these properties quite a bit when we're trying to balance the equations, like you were talking about earlier. So we're going to use these quite a bit. And hi, Garden Plaza, welcome. I'm so glad you enjoy Math Monday. So have I missed anything, folks? Before we move on, I think this is what we've talked about. But if I've missed something, or if you have any other questions before we get started, now is a good time. I don't mind spending a little bit of time on this since it's been a while. Jiggly enough, seriously, just wait till we get to like commutative property and associative. I hate that. I understand why we need to label certain properties in math. There's actually a good reason, but they aren't necessarily the most intuitive names. And I also, to be completely honest, there is zero reason I feel like you need to memorize the names. So I feel like that's a waste of, brain space in terms of trying to cram this into people's heads when they're learning algebra. No, you're never going to need to use this. The only one that I hear referenced continually as I've moved through math is distributive property, which we'll talk a little bit about today. Hi, not awful. Classical mechanics. Ooh, I've got good books for thermodynamics and quantum mechanics, but I'm trying to think if I've got a good one. So many of the classical mechanics books are quite trash. A lot of physics textbooks are trash. I can't think of one off the top of my head, but I'll try to think a little bit more. So again, though, everybody's different, and so everyone's going to like different textbooks based on your learning style, what you prefer. I love Griffiths. So his physics textbooks I found to be really awesome. So I really love his quantum mechanics. That was a great textbook, in my humble opinion. But, okay, and let's see. And Zug Addict, you say I always forget after a while which properties I need satisfied and then derive them again from an example. Yeah, so that's kind of, even though these are simpler properties, that's kind of what I'm getting at, right? Instead of memorizing the names, just kind of translate them. And that ability to translate math into English or English into math is really helpful, especially when you're working on real world problems or if you're working on word problems. So it's a good kind of habit to get into or muscle to start exercising. Because you'll use it a lot in math. Okay, speak now, forever hold your peace. I haven't seen any other questions about this or any other additions for what we've done previously. So I guess looks like I wanted to dive into inequalities. Okay. Well, actually, so since I did review, let me tell you what we're doing today. And that also can make it helpful for people who are just stopping in. So today, we're going to talk more about inequalities. we're going to do that one property that I said, the name actually is used quite a lot, distributive property. Harder linear equations, because we've done some kind of like 1 or 2 step ones. So let's get into the the meat of it, where there's some more difficult stuff. And hi, Icy Yogi, welcome. And then also if we have time, we'll start systems of linear equations. I love systems of linear equations. All right, that's what's on the table for today. So let's get started. Also, so I can keep myself organized. All right. Hi, Rinta. And yes, Raw Yolks, you ask, I'm curious, are textbooks in America also ridiculously expensive? They are. And that's one of the many ways that education is very inaccessible in the United States. And no worries, Zug Addict, ask questions if you have them. All right, so what's an inequality? What is this? We've done equations, but what is an inequality? Just look at the name. Not equal. Yes. Okay. That's a great way to think about it. And Strawberry Jesus, you ask, are Math Monday blackboards going on GitHub? They're not on GitHub, but they are on Google Drive. And you can get the link by going to the YouTube. So it's in the description for the videos. Hilarious. Okay. All right. Yes, Raw Yolks. And yes, Jay Shady. So not equal. So remember that when we talked about equations, so equations give us some kind of equal relationship, right? Equals. Equation, equal. So an inequality is talking about a relationship exactly, Jay Shady, that is not equal. Well, sometimes it might be equal, but it's not entirely equal. So this might be x plus 5 is less than 7. So the new symbols that we talked about last time were less than, greater than, less than or equal to, and greater than or equal to. I'll just write or equal. Okay. So these are symbols that you'll see used in inequalities. And so for the most part, what we did last time was we talked about how solving inequalities was just the same, for the most part, as solving equations. So solving inequalities. It's very similar. There's going to be one key difference, and we'll talk about that today. But it's very similar to solving equations. And Rinta, you ask about, okay, so that not equal to, you'll see that more in programming, but less so, that notation you'll see less so in algebra. Because you can't think about it, right? So if I have x plus 5 does not equal 7, how do I solve that? That doesn't really tell me very much, right? It just tells me one number out of the infinity that it, infinite numbers, just one that it isn't. So it's a little bit less, you won't see that as much. What you will see is when talking about the limits, and I don't mean limit in a calculus sense, I mean like the constraints that you might have on certain equations. So I might say x is less than 3, but x is not equal to 0. Something like that. So you might see it like that, but that bang equals notation is more for programming. So, all right. Solving inequalities is very similar to solving equations. So if we have the one that I've been using, x plus 5 is less than 7, just like we talked about when we solve equations, right? We're going to exploit that identity property and try to get this to be 0. So we're going to subtract 5. Oh my gosh, this is what happens when I'm autopilot. And get x is less than 2. Most of the same rules apply. So you're multiplying, you're dividing, you're adding, you're subtracting, with one exception, which is multiplying and dividing by negative numbers. Okay, so this is the big difference. Let me see. Do I have more room? Yeah, I'll go over here. All right, multiplying or dividing by a negative number. So what happens? Why is this different? And hi, Fidel Castro, welcome. So no, don't worry, you're in the right place if you want to learn more about math. And algebra has a lot of practical applications. So when we try, after we learn some of these, key principles and stuff, a lot of times at the end, that would be a great time to ask questions about applications. And once we learn enough to start doing really cool math, I'll actually bring in real world data sets and stuff, and I can show you how math is literally applied. We'll do it together. So, all right, one key difference. Multiplying and dividing by a negative number. So, as always, I let you know. You should always ask why. Why is it different? And so, let's consider an example. 10 is greater than 4. This is true, right? Okay, so we're good. This is true. I haven't accidentally written something. I always like that that check that I get from all of you, because there have been so many times where I've just been absorbed in writing something on the whiteboard, and you all are like, you've literally written 1 + 1 = 5. What are you doing? So yes, 10 is greater than 4, right? So be nice, chat. But let's see what happens when we multiply by -1. All right. So let's say we're going to multiply this by -1, and we're going to multiply this by -1. What do we get? Is this still true? Is -10 greater than -4? No, it's not. So we have to change something when we're multiplying and dividing by negative numbers in inequalities. Ugh. Getting out of that, I don't know about anyone else who, if you write a lot of code for a job, but I found that, especially when I'm in the zone and I've been writing code for hours, it can be really hard to transition back to speaking. I find myself stuttering and fumbling over my words a lot more than I normally do, just because my brain is in a different mode. So, ooh, Jay Shady, awesome. I hope you like this tablet as much as I do. It's pretty nice. I like it quite a bit. And it's pretty affordable as well. So, okay. negative 10 is not greater than negative 4. So what happens? We have to change our sign here, right? So to make this true, we would need to flip the sign. So negative 10 would be less than negative 4, and then it's true. And so that's the rule. That's the rule that we have for inequalities. When you multiply or divide by a negative number, you flip the sign. So let me summarize that actually for those of you who are taking notes. Or dividing by negative numbers, flip the inequalities. How would you say that? Like a not like an operator. It's like there's got to be a math word for it that's escaping me. Let's see. Zug Addict. Well, that's why we have wonderful mods, right? Let's see. Relation, maybe? Yeah, like, I mean not the sign as in the, I guess I'll put symbol for now. Symbol or relation. But I mean the greater than, less than, etc., this stuff. All right. So this is the rule, and this is why. And this is another case. Yeah, Smallins, you say you've referred to it as flipping the inequality before. So I'm trying to be really precise because, not everyone knows, for example, what inversion means. And that can mean a lot of different things based on what discipline you're in. And flipping it, I could see somebody just like preserving flipping the whole thing, like mirroring it instead of only flipping the symbol or something. So I'm trying to be really specific. But I've heard that as well. And Shu King, you said comparison symbols. That's a good term. Okay. So this is another case where I find a lot of people memorize this, but they don't really understand why. And so I like kind of, even though it's very simple, 10 and 4, I find that just showing this, it makes it a little bit more intuitive because you're like, oh, yeah, okay, that makes sense. The only way that we can keep using this symbol and throw negative numbers into the mix is if we remember that it reverses the relationship as well as kind of inverting the numbers. And Aaron's here. Thank you so much for subscribing. 6 months? Oh my goodness. Thank you. Happy 2021. Thank you. That means a lot. And thank you for contributing to my birthday goal. And Jigglynuff, rotate the symbol. See, this is the thing, is that once you've been teaching, especially if you've been teaching kids, you start to realize all the ways that they can break things. And I feel like it's actually kind of similar to sort of thinking ahead to how users are going to use your software, where you're just going to assume that they're going to make the bad decision. So if I say rotate, there's going to be some kid doing that. So again, these are great ideas. It just is that kind of I'm trying to be really careful about how I explain the rules. And Nayato Cat and Jeff C. Groves, welcome. Happy Math Monday. Welcome to Math Monday. Okay, so inequalities, like I said, you solve them pretty much the same way that you solve normal equations. The one difference is going to be when you bring negative numbers into the mix with multiplying or dividing. And Smolliants, you say you don't want them doing bitwise operations too early. Okay, so let me think. I guess the only other thing I'll do is a quick reminder of what it looks like when we graph inequalities. Because I know that we did that last time. But it's been a while. Oh, man. Is it just me or is like the whiteboard lag extra today? Inequalities. There we go. There's a a condition of just when you're writing on a whiteboard or a blackboard, and apparently not just when you're, using an actual one, but also a digital one, where I just misspell things so much more often than I normally do. I think because I'm thinking like 3 or 4 steps ahead and my hand can't write as fast and I'm trying to be neat, so I try to slow down. A little bit of lag, yeah. I'm getting that too, so, which is weird because I don't feel like I've written a whole lot yet. So come on, whiteboard. Stick with us. I'd get another whiteboard app, but I'd be very sad to lose our really pretty starry font. So, okay. Graphing inequalities. I'll just do this really quick and give you all an example of what it looks like. So, I've been drawing different graphs today. So, all right, there we go. And Rinta, you say, you remember this rule by the number line. The bigger the positive number, flip it would get the smaller negative number. That's actually a really great way to think about it. So if this doesn't work for you, another way that you can think about it is via the number line. So right? So if we're dealing with 4 and 10, right? 4, actually, let's see, I had 10 is greater than 4. So 10 is to the right of 4, right? It's greater. Greater than. But when we multiply, suddenly the 10 has also switched sides. It's no longer to the right of the 4, it's now to the left of the 4. So if that kind of directional visual cue works better, then follow that. Let me also make sure that this is a negative. That's one way to think about it. If kind of thinking about it in terms of the inequality itself, you're not going to remember that. This is another great way to think about it, is that when you multiply by the -1, think about it. The numbers are actually switching places in the number line as well. So makes sense why we need to flip our what did we say they were? Comparison symbols. I like that. All right. So let me just make up an equation here. Yeah, that'll work. Let's do. So let's say we have y is greater than or equal to x plus 1. And so all I've done for now is draw the line y equals x plus 1, because we know, because of this nice equals, that that's part of this too. And then I finally get to use the fun highlighters. Think about it. Y, this is our y line, right? And our y is increasing. Let me label this. And as we move up, y is increasing. We know y is greater, so we want to say that whatever this x plus 1, this is x plus 1 right here, y is going to be bigger than this or equal to it. So we shade and we say, hey, y could be any of this. And that's how you graph an inequality. Now, if you lack this equals, and instead let's say it was y is greater than x plus 1, you just draw a dashed line instead to kind of indicate that you don't have, y can't equal x plus 1, but this still is the boundary. So let me see, if you say alligator, yeah, that's, a lot of people I think learn that in school, is that it's like a mouth eating the bigger thing, right? Pac-Man, I think so. I think for a lot of students now, they might be like, what's Pac-Man? And then I would feel really old. So now we're getting into hot water really quickly. It's not hot water. It's just think about it like how when we were visualizing inequalities on a number line, we would use an open circle versus a filled in circle. This is just the equivalence here as well. And band low key, you ask, couldn't x be a negative number? Yes, absolutely. So x goes, x goes negative over here. So actually, let me think, 0 minus 1. So this is actually negative 1 right here. So actually, my 1s and my 2s kind of look similar when I write them like that. So let me rewrite this so it's clearer. But absolutely, so x becomes negative here on the left side of the graph. This is all where x is negative. So I think you might be asking about, oops, where's my highlighter? I was being a little bit lazy, so obviously this does continue down here. So all of this we would want to color in. Hopefully that helps. But you're absolutely right. This line continues all the way down. I just didn't draw the full thing. Hi, Def Hacker, welcome. Okay, so that's a little bit of a brief preview into graphing inequalities. Let's see. And I wanted one brief aside. We can talk about that later, actually. So let's, it's going to seem like a bit of a change in topic, but let's talk for a second about distributive property. Because before we move on to any kind of harder equations, we got to know how to handle this. All right, distributive property. So distributive property lets us know what we can do when we have something like this. So yes, you can just add the two numbers together. So that's one way we can do this, right? And I remember telling you that when you have nothing in between a number and the parens, it's a little bit of like math shorthand. Like there actually is like this secret multiplication symbol there. It's just that it's kind of like a cursive, or how we write contractions in English, you know, like this, right? We kind of smush it together and we drop something, we abbreviate. So this is just a mathematical abbreviation where we don't actually write the multiplication symbol. But that's what's there, and 2 times 4 is 8. The other way that you can do this, and we're gonna use simple numbers first, before we start throwing, variables and stuff in there. But the other way that you can do this, which is just the same, is that you distribute the 2. And what does it mean to distribute, right? You just pass it out. So just like you think about passing out flyers or handing something out, we're going to hand this 2 out to each of the numbers in the parentheses. So first we're going to hand it to the 3. We need to keep our plus sign, and then we're going to hand it to the 1. And we get 6 plus 2, which is 8. And Borlato, thank you so much for following. And you might ask yourself, who the heck would do it this way? This is ridiculous. It's so much easier just to simplify it this way. I'm with you, but what happens when we have this? Well, previously, without the distributive property, we wouldn't be able to do anything here. We'd be stuck. We go, okay, well, that's all I can do. But now that we know that we can pass what is on the outside into what's on the inside, becomes a lot easier, right? So we have 2 times x plus 2 times 1. And just the same with, just like we have our math abbreviation up here, we abbreviate this as well, just as 2x, and 2 times 1 is 2. So really basic numbers, really basic variables, but hopefully you get the idea, right? You're passing out whatever's on the outside to each of the things that's on the inside. Actually, you know what? I realize that the way that I wrote this might be a little confusing. So, oh, and that's a mess. All right. Without distributive property, like I said, we can't go anyplace with this. However, with distributive property, it gives us a way to simplify things a little bit more. Distributive property is really the socialist property. That's a great way to think about it. If that helps you remember what it is, then absolutely. All right, so you might be asking, why do we need this? Why do we care about the distributive property? And I'm going to show you. So let's take a little bit of a harder example for an equation to solve. So why do we care? I always felt like, I don't know if you all had this experience, but I feel like whenever I feel like I never asked this question, like, why should I care? Because it always came across as rude, right, in class. If you're like, well, why should I care about this? When really I think that's actually, like, a very good question to ask, and teachers should be prepared to answer it. So it's, I don't know. It's, as I was writing it, it just occurred to me that I have this perception of this being like a rude question to ask, but it's not. You should feel like you can ask this question. Why should we care about this? Well, let's take an example. Like this. Okay. And yes, Steph Hacker, you say, if I ever teach math, I'll make sure to include a why do we care section in each class. Exactly. And I find that it can be difficult if, every bit of math does have some kind of relevance, but it might not be relevant to that student. So I feel like this is why I wish that we stressed more applied math when it comes to general education, and allowed students to explore kind of more theoretical math if they were interested in it. But I think kind of the love of STEM, which I'm right there. Okay, I'm like a lover of STEM too, but I feel like it's led us to kind of shove massive amounts of math at everyone when I don't necessarily think that's relevant. I think that more so than calculus for your average person, being able to interpret statistics and understand distributions and stuff like that is way more important and impacts how they consume media and the news reports that they read and things like that. But we'll see. Did I do this weird? I did this weird. Hold on. I was making this up on the fly. This isn't gonna work out. Hold on. I think I goofed it. And Jell and Celtic 426, thank you so much for following. This is what happens when I try to make things up on my in my head as we're doing it. Hold on, give me a sec. Yeah, that's not gonna work out. So instead, let's do let's do that. There we go. Yes, that works. Okay, sorry about that. Woo! All right. And yes, Zug Addict, thank you. Let me write that out because you're absolutely right. So this works the same way, even if we wrote this like this. Obviously, you'll usually see this, but just in case you ever, in the process of simplifying something, come across this, they're the same. So thank you for pointing that out, Zug, because that's a really great point. Okay, so if we were to come across this without the distributive property, the only way that we would be able to try and solve this would be to divide by this 3, right? Because this 3 is being multiplied. And then suddenly we're going to get things like 2/3 x and 5/3, and suddenly things get really messy and unpleasant. And so the distributive property is going to give us a much better way to tackle this without needing to divide all of this by 3 and get something kind of gross. Well, you wouldn't even get 2/3 x actually, because this whole thing would be over 3, and then you'd be right back where you started. You wouldn't actually really be able to simplify it too well. Yeah, I don't want to do that. I was thinking, oh, could I show as an example, but no, that gets messy. Let's not do that. All right, so instead, let's distribute. So what do we get? What does this become? Gives me a chance to, I always, my voice always runs out far more in Math Mondays. I think I just get overly excited. Excited for math, so I lose my voice. All right, what does this become on the right side? Soviet distribution, jiggly enough, gives us 3x plus 3. You got it, right? And so I'm going to, until everyone gets really, really comfortable with our steps, I'm going to write out every single step. So, right, we're going to distribute this, and this is what we get. Simplifying this, we get 3x plus 3. And then, all right, what should we do? What should we do next here? There's a couple different things you could do. What do you all feel like dealing with? Now, I'm going to give you, hi Divine Dev, welcome. I'm going to give you a little bit of a pro tip, which is if you see like, right, 2x. So remember when I went on my PEMDAS is pointless rant, right? This means we have 2 x's here. We have 3 x's here. So if you think about subtracting one of these over to the other side, well, 2 minus 3 is a -1. Suddenly we're dealing with negatives. Versus 3 minus 2 being a +1. So if you are in this kind of situation where you have, a variable on either side, the same variable, and each of them have, this is what we call a coefficient, subtract towards the side that has the larger coefficient. So yeah, exactly, Astrato. Let's do that then. Let's do exactly that. Let's subtract the 2x. And so what do we get, right? This disappears thanks to our identity property, right? We just get +0. So we're going to get a 5 here. And then this becomes a single x. And then we get +3. And so our last step here will be an Astrato. Yep, you're thinking on the right track there. Our next step, right, is to get rid of the 3. And so then we get... And that is a little messy, so I'm just going to move this down. And we have our answer. X is 2. So also, I remember one of the things we briefly covered was how to check your work. So I'm gonna do that again right here, so that it's a good reinforcement for how you might check your work. So here is our problem. And our theory, right, is that x is 2. So let's plug that in. Trying to be consistent with my use of colors. All right, so remember, if you have these parentheses, there's that hidden multiplication sign. So 2 times 2 is 4. And here, we actually don't need the distributive property, right? Because 2 plus 1 is just 3. 5 plus 4 is 9. 3 times 3 is 9. Is this true? It's true. So we were right. Always a good feeling, right? Pat yourself on the back. Aw, yeah. But hopefully this shows you why distributive property is useful. We need it desperately if we're going to try to solve some of these harder equations. So yes, you are awesome, Zug Addict. Exactly. And Estrada, you say it's been a while. Isn't there other ways to solve this as well, like quick ways? So there are, for this, I would say, you don't have to write out every step once you've done enough of these that you start to be really, really comfortable. And exactly, Def Hacker, like probably many of you can solve this way faster than we're going to do it together. But the point is to show every step, because I don't know about you, but I know this, at least in my experience learning math and physics, that sometimes the professor would skip steps and be like, well, obviously this is the next step, right? And I'd kind of be like, hey, it's not obvious to me. I don't see how you got from like A to X. So, but then I would be too self-conscious to like raise my hand and ask, you know. And even when I did actually, I had some graduate classes where I would ask and the professor would be like, oh, you should figure that out on your own time. And I'm like, so I'm not here to flex. And that's, yeah, exactly. Zug Addict. Professors like to do that to flex. I'm not here to flex. I'm here to hopefully help all of you understand math better and hopefully to love math eventually, or at least just tolerate it. And so I'm not trying to flex. So until we've done a lot of these, I'm going to take it step by step so that there's no, there's hopefully nothing hidden or mysterious. Slug Addict, yes, you say even worse when they're wrong. I had like a hunch that, at least one of the professors in graduate school, like, just didn't, like, was copying out the notes from something. It was a TA, so it was another graduate student teaching the class, and I think they just, like, didn't actually know the steps themselves. Like, they probably could figure it out, of course, but they were just copying notes from something, and so they were trying to get me not to ask questions. Okay, so before I move on, how do people feel? How do people feel about this? And Rinta, you say your problem is that you try to visualize every step in algebra. So you'll love the graphing sections then. I'm actually the opposite. So I always struggled with the visual steps. And when it came to like stretching and squeezing functions and flipping them and stuff, I hated that. And I always just wanted to see the numbers and the variables and not have to deal with the graphs. So you'll have to keep me on my toes and help me make sure that I'm talking about the visual aspects as well. Okay, good. All right, so people feel good about this. So let's do a couple more just for practice. So let me pick a little bit of a harder one. I wrote a bunch out, but now I'm like, I don't trust myself if I was wrong on that one. And that was a really basic one. I might have just been really tired when I was scribbling my notes, so we'll see. Uh-oh. What? We have negative coefficients now. Actually, you know what? Before I start using that term a lot, let me just do a little definition here. So if we have something like it doesn't matter. It doesn't matter. We're not solving it. Let me just do a little bit of definitions. I'm running out of colors. Crap. Purple. Oh, we haven't used green. How could I not use my favorite color? All right. So these are terms that we're probably going to be using quite frequently as we move not just through algebra, but, to algebra and beyond. It's like Buzz Lightyear, but math. This entire thing is the equation, okay? And Calico Jack, thank you so much for following. The entire thing is the equation, right? Because it's giving us an equals relationship. So the whole relationship is the equation. This little bit right here that doesn't have the equals, that is just kind of one part of the equation, is an expression. And it's an expression because we have at least, 2 terms, and we have some kind of operation happening. Then this is a term. The 6 is our coefficient, and the x is our variable. So, a little terminology. Because I'll start using these terms more and more because it'll just make it a lot easier to talk about different parts of the equation. And yes, the mathy term for the 5 and the 7. So these are constants. And hi, Dudeman, how are you? Welcome to Math Monday. How's your Monday going? And yes, also Zug Addict. That would be great for Renta too. 3 Blue 1 Brown is amazing on YouTube, and his visualizations are so good. Like I said, I'm not so much a visual person, but it's really cool, and he makes me wish that I learned a more visual approach to math. It's not where my brain is the most comfortable, I'll say. I tend to not think about it like that. But it's really interesting to go back and hear explanations for things that I've known for years, but just never thought about in that visual way. So he's really, really great. And Dudeman, you asked, does a coefficient have to be next to a variable? Yes, in this case. So the coefficient is representing not only a multiplication relationship here, but also it's how many of the variables we have, right? So the coefficient's going to kind of be attached to a variable. And we're not going to get, there's some pedantic stuff that we could get into with x to the 0 and everything. I'm not going to go into that right now. But we'll cover that when we get, probably factoring is where we might start talking about that. But don't worry about it for now. Dudeman, I know, right? This is why I'd rather us all take our time, and I want to answer as many of your questions, if not all of your questions, as I can, because there's so many things I feel like they leave out when they teach math. They leave out a lot of the why, and they leave out a lot of just making sure everyone's on the same page. So, all right. And Smalley to recommend Mathologer. I'm not familiar with that actually, so slightly unpopular opinion, but let me see. I'm actually gonna make sure it's clear that this is a different part. I don't like watching YouTube videos. I feel like, I don't know if that just makes me old or something, but I tend to, I don't process things auditorily very well. So I much prefer to read. So if there's an article covering something in a video, I'd be much more likely to read the article. I don't like listening to it. I don't know. I don't like YouTube videos, but in any case. But, so let's see, we were going to do a harder one. All right, let's do that, that's a good example. So is that purple? Let me ask you something really quick, folks. Is this purple too dark? I feel like this might be a little bit dark for, is there a way I can change the color? I feel like there was to add more colors. I can explore that on my own time. But it just seems like it's a little bit dark. Hi, third tier. Welcome. Thank you so much for the raid. Let me give you a shout out. My clip shout outs weren't working yesterday, but I'd love to give you a shout out. You all should check out third tier.
All right.
Yes. Pumpkin Days.
Well, let's go sell my soul to Jones Corp.
I love Pumpkin Days.
That's the factory, right? Well, I can't. Momo, an N would be nice.
So you all should check out Third Tier Gaming. He does 3D printing and cool CAD stuff and engineering stuff, as well as playing fun video games. So you should give him a follow. How dare you? How dare you sell your soul to Jones Corp though? And Dudeman, so it's a third-party plugin that I set up. What is it? It's Twitch Guru? Is that what it is? It's really easy though. It's just like a browser source. And it when you do a shout out, it just pulls a random clip from that channel. So, okay. Jones Corp is like JojaMart. Yes. You should not be supporting them unless you're, a traitor like third tier. But all right, so I also saw that this is a light enough purple. Okay. Just making sure, because like for me, it's kind of on the edge of being a little bit too dark, but I just want to make sure everyone can read this okay. Okay. It's a bit dark, best to use it sparingly. You got it. No problem. So I am going to refill my water really quick. How about you all take a whack at this one? This is kind of putting together a lot of different things that we've been talking about. Negative numbers, equations, distributive property. But also if you feel totally lost, like I'll be back in like 30 seconds, okay? So give me just a second to get more water. Otherwise, I'm going to start croaking. But, take a stab at it and see how you do. All right. How'd it go? And Mike Daleks Mazad, thank you so much for following. All right. So Jiggly Enough says -5. Let's find out. Let's do it together. I won't read any deleted messages. Okay. As long as people are behaving. Ban Lowkey says 3. All right. Well, let's figure it out. So, I'm going to switch to a slightly, I'm going to switch to a lighter color, so that we're able to see this a little bit better. So I'm just going to copy this up here. Is that all right? Yes, okay. All right. I'm not doing any solving, or I'm not doing any funny business. Just rewriting it so that it's clearer. Okay. I think the blue is still bright. I can use like the super bright blue. Okay. The Encelafrog emote? What's an Encelafrog emote? Okay. So the first thing I'm going to do, I think, when I take a look at this is do the distributive property over here. I like to kind of get rid of the parentheses as much as I can, so everything, you know, I can start to sort stuff a little bit. So, right, distribute the 4. So we're going to get 4 times 1 minus 4 times 3x. Okay, and that's just going to be simplified as 4 minus 12x. And then we can copy out the rest of this. All right. Yep, okay. So next, you said I needed water-eyed croak, so Encelafrog. Okay. I'm not even sure what that would look like, but I'll think about it. So usually what I like to do is I like to simplify each side until it kind of looks like this side, where I've got a variable and a constant, right? Here we've got two x terms, so we can actually simplify this. And this might feel a little bit strange, so I'm actually going to reorder this so we can see it a little bit better. So we've got minus 2x minus 12. And if you're wondering, how do I simplify this? Why? There's x's in the way. What do I even do? Okay. All right. Let's like take a little bit of like a breather over here. Ignore the x. Solve the coefficients. So -2 minus 12, right? Think about that. On our number line, we're starting at -2 minus, we're going left even more, -12. We're going to end up -14. And then just tack the x on. There you go. You did it. Easy. Easy peasy, right? So if it starts to overwhelm you to think about simplifying something when you have the variables in there, you know, simplify. I would recommend kind of simplifying it off to the side, because if you do it here, you might get confused that there's no x, and you might forget to bring the x back in. So I would recommend kind of having, like, a lot of times when I'm solving equations, I have kind of like a side portion that's like my scrap paper to quickly do multiplication or do some simplifying like this. Kosh Vader, thank you so much for following. Welcome to Math Monday, and hi, Last Smiles. Okay, so let's see here. Right, we're just taking it one step at a time, no reason to rush, so we'll copy the rest of this out. Now, see, now this side is what I described earlier. We have our variable and we have a constant. And so remember the trick that I told you with our last equation. Find, if we've got two variables and they have their coefficients, we're going to move towards the variable that has the larger coefficient. And I know that might seem a little weird since we're dealing with two negative coefficients here, but remember that -6 is bigger than -14. So we're going to move the -14. We're going to this is the thing we're going to cancel out. Cancel out the small thing. And supper slash, you scratch your head? Don't worry about it. If you have questions, jump in. If you are new to Math Monday, you're kind of hopping in on day 3 or 4, the videos are on YouTube. And all the notes, there's links in each video to the notes. So you can very easily catch up. I have a math channel in Discord. So if you get stuck or something, you can ask questions. Okay, so, right, this is, I don't know, what were we talking about? So if we're gonna move our variables, we're going to move towards the variable with the larger coefficient, or you can think about it like getting rid of the variable with the smallest coefficient. So, right, using our identity properties. Okay, and similarly, right, just like we just did, if this starts to feel like, oh God, there's x's, now I'm confused, just do it here. So -6 plus, right, think about the number line, we're moving to the right by 14. And so we're going to get 8. And if I'm moving too fast, like, tell me, okay? And we can slow it down. Last Miles, thank you for the bits. So you know what that means? It means 10 dog treats. 10 dog treats. So we'll have to take a break. Actually, it might be good after this one or the next one to take a break, and we'll give the dogs some treats with the treat machine. So thank you. And Milk the Udders, what a name. Thank you so much for following. Okay, so like I said, right, we end up with 8x here. More treats after the 500 they had last night. I know, Catalyst Creations, they're spoiled, right? Okay, and then we need to get this constant, right? We need to get rid of this constant. So add that. Actually, where are you? Go away, little tab. Oh no, don't tell me it's stuck. Ugh, whatever. I am not able to use the right colors today. There we go. All right, last step, right? And to solve this last step, you have to remember, right, about that abbreviation that I was telling you about earlier. This is a multiplication relationship, so we need to divide by 8. So, and I should be doing that in the change color. And we get x equals 3. So let's see. I think somebody had it too. Ban Loki, nice work. You said 3. You are absolutely right. But you know, we're gonna be cautious. So let's check our work. So let me copy this over here. And I'm gonna move the whiteboard, but just give me a sec. I'm really bad at copying things. I often copy them incorrectly. So I will be often relying on chat to keep me from making very silly mistakes. Okay. So we think x is 3. Okay, so let's go through. -6 times 3, right? -18. -2 times a +3, -6. And then we get -3 times 3. -18 minus 20, we're getting even more negative. And 1 minus 9, -8. Four times the -8, -32. All right, we got it right. So I know I moved a little bit fast through that, so I'm going to leave that up for a second. But as we do more and more of these, I feel like it's going to become a lot more comfortable. The negativity here is palpable. Haha. It's the only kind of negativity that's allowed, catalyst creations, are negative numbers. All right. So seriously, honestly, folks, how do you feel with this? How do you feel with these slightly harder linear equations? We can do one more. If you're kind of like, oh, I don't know, I'm still kind of like, feel a little shaky on it, we can do one more. But if everyone's like, nah, like this is easy, we got this, then we can move on. But it's up to you. Are there any other questions? People doubt. People think I'm lying to you, that it's not 3. You'd like one more? You got it, Garden Plaza. Sure thing. All right, so let me just take a look at my notes here. I try to keep everything like kind of symmetrical. So whatever. Come on, please just go back to, it does this sometimes. It's so frustrating. Go. Okay, whatever. Well, it's going to be at 106% now. Okay. Don't worry, we're not doing fractions or exponentials just yet. Let's take this one. And hi John, how are you? How are you doing? Happy Monday. How was your Monday? Let's see. Another example. And then after this, we'll do a little bit of a dog break because Last Miles was so kind and has banked 10 dog treats for the dogs. So we'll take a puppy break after this. I know, isn't this like, I love this pen. It looks like space. Oh, you took the day off. Nice. Mondays are always rough. Okay. All right. There we go. A little bit of a longer one. We got distributive property in 2 places now. But let me think. If anyone wants to take a whack at it, I would say get started. We can wait a couple of minutes. But also if I start solving it and you're not done yet, like feel free to mute stream, finish the problem. Sometimes just for the sake of time, I have to kind of jump right into it, but feel free to take your time. There's no time pressure. And just because like I'm starting to solve it doesn't mean that you're slow or anything like that. So I know at least for me, a lot of times I like to take my time when I do math. I don't like to rush it because when I rush it, I make mistakes. But yet there's this pressure in school to move fast, right? Because somehow doing your math fast means you're smart. When, at least for me, I'm like, well, I get it right more if I take my time and I don't rush myself. So don't feel rushed, but I'll give it a couple minutes, look over chat for a sec, see if I've missed any questions, and then we can do it together. But let's see. Oh, let's see. Supper slash. I think I did miss your question. I'm sorry. I have an issue with scientific numbers. Ooh, yes. Okay. So we haven't gotten to negative exponents yet, but if you stick with us, stick with the crew, we're going to go through negative exponents. And I hope that at least when I taught negative exponents in my mom's classroom, kids seem to get it. People seem to enjoy like the way that I did it. So fingers crossed it'll work for you. We're not talking about that today, but hopefully hopefully you'll be here when we do. And if not, the videos are all on YouTube, so you can always catch up if you've missed a stream. Let's see. I think other than that, I don't think I've missed any questions. I had to scroll quite a bit up, so. Okay. And Nova Dies, yeah, so I used to teach in classrooms. I tutored for many years, so one-on-one, and then I would hop into various classrooms for free and do like either pulling students that were really struggling in math and working with them one-on-one, or like grabbing a small group of students, or just kind of doing like coming in and guest teaching like a science classroom. But funnily enough is that teaching, I wasn't technically hired yet, but they were considering hiring me. And so it felt a little like getting fired, but that's like the one time that, like, I don't know, I've come close to or felt like I got fired was actually when I tried to teach public school. And they basically were, it's weird in the United States. I feel like there's I don't know if it's like this in other countries, but like, you know, especially in elementary and middle school, teachers can get fired for like having pictures of themselves like holding an alcoholic beverage, even if they're old enough. Or like obviously if you're doing illegal stuff, fine, whatever. But like I work a lot with disability advocacy, and they did not like that I used the word disability. They said that it was a negative word, and that would be a problem essentially. And I just realized that like I feel so much compassion for public school teachers, because they really are kind of chained to a curriculum, and there was very little flexibility for teaching things in different ways, or for kind of taking a little more time on one topic if your class was struggling with it. And so I just felt like that would kill my love of teaching, I think, if I had to teach in public school. So, yeah, but I love tutoring, and I still volunteer in classrooms all the time. So, also the entire like disability advocacy movement disagrees with them on that, but you know, we won't go into that. But in any case, I realized it wasn't for me. But I like teaching. I like teaching in a way, though, that like helps the most amount of people and removes the most amount of barriers to education. So I actually think that working in a public school wouldn't give me that feeling, because at least through Twitch, like obviously you need an internet connection or like a cell phone with reception and stuff and a device to be able to watch it. But other than that, like all of this content is free. You can take it, you can have it. It's for you to use. I think I'm going to work on some kind of like Creative Commons license. So if like teachers use the content, they just need to like, you know, give me a shout out or give me credit. But this way, I don't know, I can answer all of your questions. We can take it at whatever pace we need. I don't feel like a pressure that, well, the test is next week, so I got to get through this, stop asking questions. Like, there's none of that. So, in any case, alrighty, let's, yeah, so we had a couple different people having different answers here. So let's do this together. So, like I said, I'm going to be let's get rid of our distributive property first. And commentator, no, you don't need to raise your hand. You can ask questions whenever. If I don't get to it, just tag Loafbone and he can highlight it for you. He's the mod. And so if I miss it, if chat's like, you know, a little dense, I might miss a question or a comment or something. And you can tag him. And no worries, Def Hacker. I'll see you in a little bit. Okay, so let's take this first little expression here, right? And let's use our distributive property. So we're going to distribute the -3. Okay. And so negative 3 times x, right? We're just going to use that abbreviation. And then negative 3 times a negative 1, right? We get a positive 3. And if that confuses you, I'd recommend going on YouTube and watching the last Math Monday video. I did a deep dive into why multiplying 2 negatives together actually makes a positive. So if that confuses you and you're like, oh, that makes no sense, I would encourage you to watch that video. Okay. And Ant, you're more than welcome to share. You're more than welcome to share your answer in chat. Lots of people were putting their answers in, and we'll check it. We'll see. Okay, so now I want to tackle this expression, and let's distribute the 8. Okay, so 8 times x minus. So I'm going to be very careful here. So plus 8 times a negative 3. And we get 8x minus 24. And let's write that all out. So we got negative 3x plus 3 plus 8 minus 24 equals 6x plus 7 minus 5x. Okay. And so now let's start to simplify this a little bit. So, and I'm going to take it, just trying to make minimal changes per step so that it doesn't, did I miss an x? 8x. Where did I miss the x? Oh my goodness, thank you. Ha, you all are wonderful. Thank you. Typos happen, and especially if I'm speaking while I'm writing, so thank you. Chat, that is awesome. Also, Sizzlor, thank you for following. I remember talking to a teacher one time about, like, they would get really, really embarrassed when they made a mistake on the whiteboard. I'm like, no, it's a good thing, because if your class catches it, they're paying attention. They're following. They understand. It's great, because mistakes are going to happen. Mistakes are a part of math. And if you catch it, that's awesome. That makes me feel so great, because it means you're actually like following, right? It's great. And Intro Pervert, what a name. Thank you so much for following. Welcome to Math Monday. And Papa Smurf of Death, you say, I haven't used algebra in years, really making me think. Well, I'm glad. Welcome. I'm glad you're here. Hopefully, we're kind of learning some of the basics and the theory now, but we're going to do lots of cool applied stuff. So hopefully you'll stick around for that and see how you can keep using algebra. And Mediocre Gamer, you say, I always appreciated when teachers didn't make a big deal out of a mistake. Normalizes that everyone makes mistakes and it's okay. I agree. And I also think that's why I don't like a lot of like kind of the modern public school math way of testing too, because like I don't want to mark an entire thing wrong just because of a typo, essentially, because a student like, oops, they're stressed or something on a test and they dropped a negative. Like, if you can tell, you can look at the work and clearly understand when a student understands it. Like, I think that we should be testing for understanding, not testing for perfection, because perfection is unattainable. If we need perfection, we have calculators and computers, but that's not the point of teaching. The point of teaching is not to have perfect rote memorization. It's understanding. And I understand this stuff super well, and look at that. I made a mistake, so, it happens. All right. Let's start combining things. I think commentators said collect like terms. Yeah, that's a phrase that you'll hear a lot in math. It means like combining things that are similar, right? So in this case, we've got, I'm going to use a light blue, right? We have a term with x here, and we have a term with x here. And so remember, if it helps you, kind of do that sidebar and solve the coefficients without the x. But here I'm just going to, negative 3x plus 8x, we have 5x. And I'll take it. I'll do one change per side so that it doesn't. And over here, we have 6x minus 5x. That's an easy one, right? So that's 1x, or just x, plus 7. Okay, see? And this is what I love about algebra and about a lot of math, right? Look at this mess up here. This is horrible mess. And look, like we're slowly neatening it. We're slowly making sense of that chaos. And I love that feeling. It feels so cool. Okay, so now we've got plus 3, positive 3, minus 24. So we're going real negative here. Okay, and now we're back to that situation, right, where we have variable and a constant, variable and a constant. So now it's time to start moving things like from side to side. And right, we find the variable with the smallest coefficient, which is this one, and this is the one that we're going to move. So, and 5x minus x, we're just going to get 4x. All right, and now let's get rid of this negative 21. Let's add it. Okay. We get 4x equals 28. And our last step here is going to be to divide that 4. Let's get rid of that 4. Okay? And we get x equals 7. There you go. We did it. All right, how did that feel? We had a whole lot of different answers in chat. Don't be worried if you didn't get the right answer. Take a look at this and try to find your mistake, because I feel like it's a really helpful thing to go, okay, well, I didn't get the right answer, but that's okay. Where did I screw it up? Because not only is that going to help you, maybe not make that mistake in the future, but also that act, literally, just that act of like looking over your own math and trying to find the error makes you better at math. So it's always good to take that step if you can. So, but if you're stuck and you're like, oh God, I don't know what I did wrong, take a picture of your work, post it in the Discord, put it on like an image hoster, send the link to Loafbone or put it in the Discord and we can take a look. If you're like nervous and you don't want people to know that it's you, feel free to just DM it to Loafbone and I can take a look and walk you through and help you find the mistake, okay? So if you're struggling to find your own mistake and you're like, I don't get what I did wrong, feel free to send your work over and we can take a look, because it's good for all of us, right? It's always good practice to look over math and try to find the errors. But all right, there we go. Good job, friends. And Garden Plaza, you got it exactly. So you reading my mind, friend, as to our next step here. Let's change up our colors. Getting bored of these colors. Let's do the light blue and the dark blue. And Lizard, and nope, I don't have my PhD. Our theory here is x is 7. Okay. Math is amazing, Lizardin. Exactly. I can't wait for us to get to calculus too. That's some of my favorite math. So I know, and you mentioned Microsoft Whiteboard being a better piece of software. It's pretty good. It's held up fairly well for me. it lags sometimes, and I wish it didn't. So I wish it was a little less laggy, but it's pretty good. And Lizard, and thank you for following. And Brozak, you say, I call it my homework to learn rather than to get it done. I feel like, and okay, unpopular opinion here possibly, but it's like one of my soapboxes when it comes to teaching. I don't, like, homework should not be graded for accuracy. Homework should be graded for, like, did you do it? Did you attempt it? Did you try? And by grading the practice for accuracy, you're overly penalizing students, and you make it so that they're afraid to make mistakes. Like, mistakes are part of learning. It's literally how you learn, okay? And it's also how computers learn, machine learning, right? You learn by making mistakes, by making errors. And it's so frustrating to me because it creates this overly punitive system where, I don't know, where students are more afraid of they see mistakes as getting it wrong, as having a less good grade, rather than like, this is part of learning, is getting things wrong and figuring it out from there. Like, it just, it makes me so frustrated when I see that, because it hurts students, and it makes them learn in ways that aren't healthy and aren't helpful. So, I think, absolutely. So I agree, Ant. Like, teachers should check the answers, but it shouldn't affect the grade, because one of the things that always frustrated me in graduate school is, like, I would be doing some of my physics homework, and I'd get stuck, and I'd be like, I don't know what I'm doing wrong. And so I'd try different things, and I'd, like, have notes of, like, here's what I tried. It didn't work, so I did this. And they'd just be like, well, it's not right, so you don't get any credit or something. I'm like, you can look at this and see that I tried so many different things and I was stuck, but I gave it everything. So to me, I would have learned so much more from a teacher taking the time to look at it and go, like, here's your error. Like, try doing this next, or like, try using this equation or something, versus just -10. And you're like, how does this help me learn? It doesn't. Like, it's ridiculous. And Space Fun Club, you say, you're here to get grades and improve the school system's administrative KPI for government reporting. Truth. Yeah, the problem is that if you want to, like, I don't know, learning doesn't happen. Like, literally, there are studies showing this, having to do with like cognitive science, right? That the hormones or like neurochemicals or whatever they are that are released when you're very, very stressed and when you're afraid actually inhibit learning. Duh. You'd think that's kind of like a duh, right? So the more we stress and freak out our students, the actually less able they are to learn. People learn best in positive environments with positive reinforcement and, like, not being terrified that they're going to fail, obviously. It just drives me bonkers. Okay, Deaf Hacker, I will hydrate. Thank you. And Catalyst Creations, you do bring up, like, it's not, a lot of times it's not the teacher. Like, it's not the teacher's fault. They have so many students. And grading takes way longer than you think. Like, I would try to be really thorough in my grading when I was a TA in graduate school. And, like, give students really good feedback and, like, kind of address where they got it wrong and things like that. But it took so much longer to do it that way, for sure. But that's a rant I could go on for a while. Is education. Goodness. All right, let's test out our answer here. And then after this, we'll take a dog break. Give the dogs some treats. It's good to reward yourself and also reward my dogs when you've done a chunk of math, right? I was dealing with this very frustrating bug in my work code today, and when I finally figured out and I finally solved it, not only did, like, the endorphins and the elation feel great, but I was like, I'm gonna reward myself. So I let myself play, like, a run of Slay the Spire on my Switch, and I was like, I get to put my feet up, and I'm gonna play a video game because I've been working at this bug for hours, and I figured it out. So, reward yourself, treat yourself. All right. Okay, mediocre gamer, have fun. All right. Let's see. Okay. All right, folks. -3 times 7, -21. 6 times 7, 42. And if you're, shaky on your multiplication tables or anything, like I still struggle with my 12 sometimes, don't feel bad if you're using a calculator for this. That doesn't mean that you don't understand it or whatever. Like, it's totally fine to use tools like that. Like, calculators are your friend. And I'm trying to restrict myself to changing one thing on each side of the equation for each line so that there aren't too many changes. Because I found that, especially when people are learning, if I change too many things or do too many steps in a single line, there's a higher chance people will get lost. So I'm restricting myself. I simplify one thing on either side per line. And you can see what's been changed because I'm changing the colors. So the colors are a clue for what we simplified there. And so let's see. Eight times 7. And -5 times 7. And yeah, Lizardin, exactly. You say, I've had many answers wrong for doing multiple steps in one line. I've actually found this to be something, especially with some of my really bright students, where like they kind of want to flex, and so they want to see how much they can do in their head. And they're like, I'm smart enough, I can do it in my head. I'm like, you want to know what really smart people do? They write it down. Like, it's almost like that sophomoric thing, right? Like where real beginners do something, and then like that kind of, middle ground when you have a lot of confidence but not as much knowledge as you think. It's kind of like that phase. Because especially if I'm working on something really complicated, sometimes I'll even do this. Even when I'm like, I'm confident, like I know my math, I'll actually hold myself and be like, just change one thing because it's going to be a lot easier to go back and check your work. And especially if you're dealing with something complicated, it can get really tangled if you're taking too many steps at the same time. 3K0D, thank you so much for following. And Commentator would say, I always tried to flex, I always made mistakes. Me too. Right there with you. This is the wisdom that comes with many years of making mistakes in math. So I was definitely like that too. But I think part of that is because like the culture of the classrooms I was in made it seem like if you were really fast and you could do it all in your head, then you were smart. Versus like, no, it's smart, like I said before, to take your time and be thorough. Like that's smart too. All right. When solving linear equations, systems, flexing is especially fatal. Agreed, Zug Addict. Agreed. All right, so let's keep simplifying. -21 plus 3. I'm gonna get -18. 42 plus 7. I'm gonna get 49. Okay, now we're getting fun here. -18 plus 56. I'm going to try to... Nope. I'm not going to do that in my head. Because I am on stream, and knowing me, I will make some kind of mistake. So... Okay. Actually, I can simplify this. I didn't... 49 minus 35, we've got 14. And 38 minus 24, 14 as well. All right, true. We got that right as well. And hi Cassie, hi Raiders. Welcome to Mathematics. You came at the perfect time. So we've been solving some linear equations, and it's time to take a dog break and give my dog some treats. So in my channel, if you donate bits or give bits or however you say it, those go towards treats for my dogs. So give me just a sec to get the app up, and then we'll give the dog some treats. But Brozak, you say, I refuse to substitute numbers for my symbols until I've simplified fully. I find checking my algebra far easier than trying to trace back problems in my arithmetic. Agreed. And so when we start to get way more into like more complicated problems, that's going to be, that's such a good tip, right? Is simplify as far as you can with the algebra first, and only substitute in when it's like literally the end. So just waiting for the app to load, then we'll give the dog some treats. Loafbone, can you just check and make sure it has enough treats? Thank you. Is it loading? It's thinking about it. It always takes a little bit, sorry. And Canis, you say, I used to do long division in my head, probably as rebellion against how we had this absolutely god-awful word problem solving thing we had to do in elementary school. You had to write out how you were going to solve it, then explain how you solved it. Oh, see, like, that's the thing, is that, and I know I've told you all this story previously, but I started to succeed in math when I left public school, and I stopped getting like 60 problems that were all easy for homework. And like, you know, my eyes just start melting eventually. Or like 40 of them are easy, 15 of them are medium, 5 of them are hard. Like, ugh, this is just death by math. And like, I love math, and that's too much math. And then when I went to private school for high school, we'd get like 2 problems, maybe 5 or 6, but they were really hard. And I loved the challenge, so I didn't mind doing that. That felt so much more manageable than like, here's a giant freaking worksheet of 1 million problems. Good luck. Okay. All right, let's see if we can coax the dogs over. We've got 10 treats from Last Miles. Last Miles, are you here? We're giving the dogs your treats. Hopefully you're still here. And here comes Hubble. I don't see 10. 10 might be sleeping under a blanket, knowing Tennessee. But let's give Hubble some treats. All right. I'm going to try to keep track today. So that's 2. Oh. Here comes Tennessee. So Tennessee's coming over for treats too. Here's number 3. Because usually I end up giving them like 50 because I'm just talking and I'm not counting. So I'm trying to be better today. Here is 4. I know, but each one of them gets 10, Loafbone. People gave 10 dog treats. That's not 5 for each. That's 10 for each, right? I guess, okay, I see what you mean. Whatever. We'll give them 6. Because they get a little like tip, right? Oh my god, they hear the sound. It makes like this beep beep sound. All right, one more after this, and then they've had enough treats. I know, Rinta, I can't do like the Kumon math kind of style. Like, yes, your kid will pass math and they will hate it. Like, don't do that. And I mean, I don't mean to like criticize Kumon specifically. I've had way too many students come to me exhausted, hating math after their parents made them go to Kumon for like a while. And it's tough. All right, one last treat for these wonderful boys. Oh, thank you, Jay Shady. I'm so glad you were able to stop by. Thank you for being here. Oh, There you go. Good boys. Lots of treats. See, yeah, Tennessee's getting some. Don't worry. Hopefully, Last Miles was able to see the little break for these boys being very cute. Hubble's very happy. We recently got a new whistle for him, so he's the Houdini dog. So we've got to keep him. We've got to keep a GPS tracker on him because he likes to escape. But this one also, like, it's really funny because you can look at the map of where he's been. And so you can kind of look at the backyard and see him, like, zooming back and forth, like going for a Frisbee or something. It's really cute. All right. Goodbye, dogs. We're going to go back. We're going to go back to math now. Very good pups. Very good pups. What a great... Dogs make the best break, right? Make the best break. And yeah, spoofed existence. So Sundays I do more machine learning and data science. But one of the things that I've noticed actually while doing some of the more complex math, like you can check out on YouTube, I did a 12 days of machine learning myths series. And I had some like calculus proofs and stuff that we went through. People's confusion was largely actually around algebraic things. So I felt like not only that, but algebra is where a lot of people start to dislike math, start to be confused by math. And so if I'm going to teach math, I want to teach the thing that's going to help the most amount of people. And that's algebra. That's not like super fancy calculus. Like I'd look smart if I did that, but that wouldn't actually help people. So, and I'm not here to make myself look smart. I'm here to help all of you. So, okay. Lizardin actually, so I did a proof of special relativity like, oh gosh, early, almost a year ago probably now, because I started streaming tech last March for the first time. And actually, special relativity is really easy math. It really is. It's very easy math. So GR, less so. General relativity is more complex math, but I did special relativity because that's an easier math to do with people, and the proof's a lot more straightforward. Okay, so look at this. We did examples. We got them right, like a boss. Okay. Oh, I had it at 100. No, I'm getting stuck on this. Okay, I'm gonna ignore it. I'm not going to try to make it perfectly 100. Okay, so one of the things I want to talk about before we move on to a little bit of a preview of systems of linear equations is let's talk about solving. Solving math problems. Yeah, I'm being real general here, okay? And this actually might be all we get a chance to go through today. But I heard something from a student once, and it really stuck with me. And Lizardin, this is a Microsoft Whiteboard. My student said, okay, well, I wrote down something like y equals 4x plus 7, okay? Right? And the student was like, well, there's no solution. I was like, what do you mean there's no solution? They're like, well, we can't solve it. There's two variables. I'm like, excuse me? Yes, you can. You absolutely can solve this. And I feel like there's this misunderstanding about what it means to solve something. So we've been working so far today with just one variable, right? And so our answer for a single variable was one number, right? And for now, that's going to be true. For single variable linear equations, we get a number, right? But I've shown you the solution, right? Look. But see, that's the thing, Zug, is he's not right. He's not right. A line is absolutely a solution to something. It's the visualization of all solutions to that equation. But for some reason, there's like some kind of misunderstanding or something about what solving an equation means. And I thought, okay, well, I guess that's something I take for granted is what solving something, like I just thought that was kind of, intuitive, right? And you're absolutely right, Zug. Commentator, thank you so much for following. You say, I think people think of a single solution like a number. And so this is the challenge, right? So this is a good time to talk then about solving things. So if we have two variables and everything's linear right now, so for those of you who are, more advanced in math, like let's keep exponents out of it for now. We'll get there. But with our linear equations, if we have two variables, right, then this is going to give us a line. And that solution represents, or that line represents, spoiler, all of the solutions to that equation. You absolutely can solve this. Just graph it. Or guess and check. Find something that fits. That's the less fun way, but one really easy way that you can do is you can plug in, right? Let's plug in 0 for x. 0 times 4 is 0. Y is 7. There you go. I just gave you one possible solution. But the solution to, if we have just one linear equation like this, is not a single solution. There's no one solution to this. The solution itself is a line. It's all of those dots all along the line. Every single point on that line solves this equation. And yeah, absolutely. So Brozac, there's going to be times where planes are solutions. There's going to be times where we don't have the words to describe what shape it is because our minds can't conceive of it, are solutions. But I want to push back against this idea of we can't solve this. A solution doesn't mean a single number. But remember what we were talking about a couple weeks ago. So this might be a little bit of a throwback, right? Let me write this down. Yes, you can solve it. The solution is a line. Or the solutions are the line, essentially. But we talked about, okay, what happens if you have two lines, right? Can you find a solution? And we did it graphically, by graphing them and visualizing them the first time, right? And so lots of you jumped in, great intuition saying it's a point. Okay, so if we have two lines, the solution, the point where the lines are the same, where they share a solution, right? And that's really what you're getting at, is if you have two lines, I don't even know if I can solve these. Actually, let me look at my notes and find two things that you can solve, because otherwise I'm gonna look like a bit of a fool. All right, let's say we've got, and we're not gonna solve this right now, but let's say we've got these two lines, right? If we have these two lines, we have two equations here. Their solutions are each all of the points along a line. We want to know not, what's the answer? What solves this? No, we're asking, what solution do they have in common? What solution do they share? You're asking, what is the x, y, the combination of an x value and a y value that fits both of these equations? So one of the ways I like to think about this is, I don't know, okay, this might be a really weird metaphor or example, but has anyone ever done those logic puzzles? They kind of look like my favorite, all right? I'm a sucker for logic puzzles. I love them so much. But they kind of look like, you're given this grid, and then there's there's grids sticking up kind of like this off of it, and you get a bunch of statements, right? Logical statements, and you have to kind of shade in different boxes or cross them out and figure out what the solution is to this logical puzzle. I might just be people might be, have no idea what I'm talking about. Oh no, Lizard, you hate those problems. Okay, well, I have little pocket versions that have a whole bunch of them because I love them. But solving this, okay, well, I don't want to say that it's like that because I know that you hate it, but these aren't Sudoku. So they're word problems, they're verbal logic problems. And solving a system of equations, solving multiple equations is kind of like this, right? You can come up with answers. Let me actually just find an example. What are they even called? Grid box logic puzzle. Okay, yes, this. Start a new puzzle. Sure. Start this puzzle. Okay. What? Excuse me. There we go. Give me 1 sec and I will share my screen with all of you. Zoom in so that the font is nice. All right. So here's what I'm talking about. And you've got, the sci-fi fan who works with Ash. Okay, whatever. They're woodworkers. Okay. Charges $4 less than Richard. Guys, this is an equation. This is a math equation. And, you use logic to figure out what the answers are. But here's the thing, is that we can find a set of solutions that fits this, right? So the sci-fi fan, I guess, who works with Ash charges $4 less than Richard. So Richard can't be the cheapest, right? If somebody else is $4 less than him, he also can't be $5, but he could be 7 minus 4 and 9 minus 5. So he could be this. And he doesn't work with Ash. So we're slowly narrowing down a set of solutions. But hey, this is all that this number one told us. So I could be like, well, what fits this? That fits it, that fits it, that fits it, that fits it. Yeah, totally. It fits that pattern that, we just figured out. But does it fit all of them? No. That's why we need these other equations, these other logic statements to figure out what the set of, instead of having a set of solutions, what is the one solution that fits all 4 of these equations? It's essential. That's what we're doing with the math, all right? Is that, sure, we're talking about Y and X instead of like sci-fi fans and Philip or something, but it's the same kind of process. You're asking not what is the solution for one of these? It could be a whole bunch of different things. It could be, a line of solutions, right? But we're asking what is the one solution that they all share? And that's really what we're getting at. Hopefully, if you've never seen these puzzles before, you're probably like, what the hell is she talking about? But I love these puzzles so much. Really teaches me how to, I did them for fun as a kid a lot. And I feel like it really taught me how to think, I don't know, how to think rationally. So, but I know there's numbers and there's variables here instead of phrases, but that's essentially what we're doing. We have 2 logical relationships here. And what did I tell you about equations? Equations are just relationships. So just like the relationship of Richard and the woodworker with Ash and the cost or whatever, this is a relationship too. We could say, okay, 3 times Bob's, we could substitute phrases in for this, no problem, because these are explaining relationships. But what solves one of them, we can solve one of them very easily because it's a whole set of solutions. You have many solutions that might fit. But really, it starts to get interesting when you try to find a solution that matches multiple relationships. So hopefully, if that was just a weird tangent and you're like, I've never seen these logic puzzles, I don't get what she's talking about, don't worry about it. But it's something that occurred to me the other day when I was looking through, I have these little pocket logic puzzle books. And when I was a waitress, I used to keep them in my apron. So when there was downtime, I would do my logic puzzles. But I found the little pocket logic books the other day, and so I was thinking about that. But also, if you want to practice that kind of intuition and kind of strengthen some of those math muscles, doing logic puzzles is a great way to do it. It gets you thinking critically and thinking logically, and it'll help with your math. And it's a nice break. So when I actually had students who were really burned out of math, they were kind of done, they didn't want to do any more math that day, we would do logic puzzles and logic games and stuff like that, because it's flexing those same muscles that you use for math. So, and cyanide for dinner. Oof, what a name. Thank you so much for following. All right, folks. All right. I think I try to keep myself to about 2 hours for our Math Monday streams. So that's about it for today. Are there any last questions about the content? We can go to more of like a Q&A kind of thing for a little bit. A little more casual, just chatting. And what logic puzzle books do I recommend? I was looking up that specific kind of logic puzzle. I also really like, obviously, Sudoku. What's the one that's like Sudoku, but it's I think it begins with a K, and it has operations. Do you know Ken? Yes, thank you, Aunt. Ken. And also, okay, what was the other one? Oh crap, what's the one where you make the pictures? Where like you have the pattern of the numbers and you have to try to get it to match? Help me out here. There's a word for it. I have it on my Switch. Do I have my Switch here? Yeah, I do. Let me see. It's called Picross. Or Picross, yeah. Those are great too. Honestly, like whatever puzzles, like Baba Is You, amazing language-themed puzzle game, but anything that just gets you thinking logically. Like, honestly, Baba Is You will get you thinking like a programmer, because you're essentially like debugging or like finding ways to like break the rules, and it reminded me a lot of the process I go through when I'm debugging code. And yeah, of course, Icy Yogi. I'm glad you enjoyed Math Monday. And Ban Loki, what is brilliant? I don't know all of the different apps and everything. I know kind of classes of puzzles that I really like. There was one for the iPad that had a whole bunch of different kinds of logic puzzles. Like some of them had trees, some of them had like, I remember something with like different shapes. But anything that kind of gets your brain thinking that way. And I don't play chess, actually. I did when I was a lot younger, but I haven't in many years, like probably 20 years. And Jake, does playing Factorio count as logic puzzle? Well, I've been playing a lot of Dyson Sphere Program and Satisfactory. And I don't know, I don't feel like those make me think as much as it just is very soothing to create highly organized structures. I didn't say, I'm sorry, Baba Is You. That was me probably mumbling a little bit. Baba Is You. So I've streamed it actually before. It's a great language puzzle game. Really inventive, really cool mechanics. I don't know, just really neat. So yeah, Ant, right? The mechanics are so cool. I remember the first time I started playing it, and it just was like this, whoa, this is really, really neat. I didn't expect that kind of mechanic. And let's see here. All right, so if nobody's got questions or anything, Dino Saturn, thank you so much for following. And Ant, exactly, yeah, you kind of write the rules of that game as you play it. It's really, really fun. Let's see. Pumpkin Days is streaming. Okay. I know it's not a science. Well, no, science and technology. Oh, she's doing dev stuff. Cool. Okay, so we're going to raid one of my favorite channels. Momo is amazing. Her art is brilliant. She's the lead dev on Pumpkin Days, a really fun like farming game. Please like stay a little bit, chat, say hi. Her stream is wonderful. It is like the most positive community I've ever seen. But I'll see you all Thursday for game dev, maybe before for a co-working stream. Don't forget to join Discord. Bye, friends.